Alright, so continuing on in section 7.4. What's going to happen here is I'm going to do some of the problems, and then you're going to do some of the problems, and we'll see how it goes. Alright, so part A. Cosine theta equals square root of 3 over 2. Solve, give exact values when possible. Cosine theta equals square root of 3 over 2. Is that one of the ones we've memorized? Is that one of our famous ones on our chart? Yes. So theta is? That is correct. It is the inverse cosine of square root of 3 over 2. I'd like an answer with a pi in it, though. Pi over 6. So one answer is pi over 6, and then, of course, everything coterminal to it. And then what's the other answer? When you're dealing with cosine is very easy. You can use positives and then negatives. So the other correct answer is theta equals negative pi over 6 plus 2 pi k. All right, I'm going to skip B, put on a C. Because that's one that you're going to do in a few minutes here when I'm all done talking.
Okay, I have a question.
Go ahead.
So if you plug like 11 pi over 6 instead of that, would that be wrong?
Absolutely not. It could be written that way. Because if I take minus pi over 6 and I add 2 pi, I happen to get 11 pi over 6. So if you want to write it as a positive angle, that's perfectly fine too.
Okay.
Either's good by me. All right, how about sine of theta equals negative 0.9? Negative 0.9, is that one of the famous ones we know? No, so what do?
Theta equals the inverse sine of negative 0.
All right, so I'm going to grab my calculator and approximate. 0.9. What's that? Absolutely, calculator should be in radians. I got negative 1.12. And then, of course, it would be plus 2 pi k. But it's sine. All right, so where is this angle? Where is negative 1.12? Which quadrant? 1, 2, 3, 4? I hear a vote for 4 and a vote for 2.
No, 2 would be positive, so it's either 3 or 4. It has to be 3.
All right, so sine is negative in quadrants 3 and 4. So this is either in quadrant 3 or quadrant 4. Where is it?
Pi is 3.14. So it's going to be quadrant 4 because it goes backwards.
All right, here's the better answer. You are correct. It is quadrant 4. Claudia said it a long time ago. Here's the better answer. When I use this sine inverse thing, where does it give me answers? Quadrant 4. Sine inverse, when I use sine inverse, I only ever get answers in quadrants 1 and 4. Clearly, this is not in quadrant 1, so it has to be in quadrant number 4. So this is our answer in quadrant 4. Now, we also need another answer where? In quadrant number 3, because sine is negative in quadrant 4 and quadrant 3. All right, so how do I get the answer in quadrant number 3? Pi minus that? All right, so I think we got to draw a picture.
Well, it's negative, so you need pi plus that, not that.
Minus 1.12 would be right about here, say.
If you did pi minus that, and pi plus that, it would be above.
Yeah, if I do pi minus that, pi minus this would be 3.14 plus 1.12. Not sure if that's right.
Well, you did pi minus a negative number. pi in the thing. It's like basic math.
Yeah.
4.12, so you have to do pi plus that number. That way you get all of pi, which is the bottom, and then subtracting the 1.12 you see there.
All right, well, here would be my answer. This angle would be 1.12, but I really want this angle down here in quadrant 3. So that angle in quadrant 3 is the 1.12 plus pi. So my other answer would be 1.12 plus pi, which is 4.26. Oops, 4.26 I said, plus 2 pi k. That's how I would write it.
But it's not negative.
It doesn't have to be written as a negative. If I take sine of 4.26, 4.26 is in quadrant 3, so sine of 4.26 will give me a negative number. Just because this number is negative doesn't mean I have to write my answer with a negative answer. And pi minus negative 1 would be exactly the same thing because it would be pi plus 1.12. All right, I'm going to skip D, although that's not a 0 there, that's a theta. It just looks like a 0. I'm going to go to E. All right, what would we do with E? Add 1, 9, sine squared theta equals 1. Divide by 9. Sine squared theta is 1/9. Square root both sides. So sine of theta, and remember when you do square roots, there's 2 of them, plus and minus, square root of 1/9, which would be plus and minus 1/3. 1/3. Is that one of the special numbers that we've memorized? Nope. So I guess I have to do sine inverse. So theta is sine inverse of 1/3. And my calculator says .34 plus 2 pi k. All right. What else do I need? That's in quadrant 1, correct. Where else do I need answers? What about 2? Uh-huh. So because I have a positive 1/3 here, I need an answer in quadrant 1 and an answer in quadrant 2. Because I also have the negative 1/3, I need an answer in 3 and 4. I need answers in all 4 quadrants here. Because I have the positive, sine is positive in 1 and 2, and I have the negative, sine is negative in 3 and 4. So I actually need to have 4 answers this time.
Well, that's your quadrant 1.
That's my quadrant 1.
Quadrant 4 is just going to be negative.
All right, so quadrant 4, I could write as negative 0.34 plus 2 pi k. That would be a correct answer. That would be the answer in quadrant 4. How do I get to quadrant 2? So another answer is pi minus 0.34 plus 2 pi k. And of course you could grab your calculator and round that to the decimals if you want. And finally, how do I get to quadrant 3? Or pi plus 0.34 plus 2 pi k. So there's all of the answers. This one we needed 4 answers. Because of the plus and minus, we needed to hit all 4 quadrants. Questions on that one? All right. Hey, there's more on the back side. sine squared theta minus sine theta minus 1 equals 0. How would you solve that equation? Unfoil it. The proper term for unfoil is called factor. We would factor. Alright, so we're going to have two parentheses like so. How do I get the 2 sine squared to show up as the first term? Pretend, if you will, for a minute that you had 2x squared minus x minus 1. How would you factor? Well, a sine theta and a sine theta, if I start to foil sine theta. Right, just like here we would need a 2x and an x to get the 2x squared. So here we need a 2 sine theta and a sine theta. And then how do I get the 1 on the end? Well, there's only one way to get a 1. That's a 1 and a 1. Again, 1 and 1 over here. And then I got to check my signs, and I got to make it come out with a negative 1 in the middle. I do think it would matter. For example, if I put the plus here and the minus there, when I do FOIL, I'm going to have on the outside a plus 2x, and on the inside a minus 1x. That would give me a plus x, which tells me what? Those are in the wrong spots. It should be the plus here and the minus there. So same thing over here. I need a plus 1 and a minus 1. All right. Well, now that we factored, we take 2 sine theta plus 1 equals 0 and sine of theta minus 1 equals 0. First one's the same as sine of theta is minus a half, and this one over here is sine of theta equals 1. All right, first equation, sine of theta equals negative a half. Is that one that we've memorized? Half we know. So sine of what gives you a 1/2? Pi over 6. Except we have negative 1/2, so our answer is going to be negative pi over 6 plus 2 pi k. That's the answer in quadrant number 4. That was in quadrant 4. 3, 1, 4. That's right. Pi. So I need an answer in quadrant 3. To get our answer in quadrant 3, it would be pi plus pi over 6, which is 7 pi over 6 plus 2 pi k. All right, and then we got to do the other one. Sine of theta equals 1. Is that one that we've memorized? Yes, theta is pi over 2. And that's the only spot. Sine of theta equals 1, you only get one answer. Pi over 2. Plus everything coterminal, of course, goes 2 pi k. Questions on that one? Alright, finally, I'm going to skip down to number 2 here. Sine of theta, or cosine of theta equals a half. Solve and list 6 specific solutions. Give exact values when possible. Okay. So theta is. Give me one answer. Pi over 3. So pi over 3 plus 2 pi k. There's one answer. Well, an infinite number of answers, actually. And how about the answer in quadrant 4? Negative pi over 3 plus 2 pi k. All right, so to list the 6 specific answers, I would let k equal 0. If k equals 0, I get pi over 3 and minus pi over 3. So I plug 0 into both of these. So there's two answers. Give me another number that you like for k. K could be 2. Skip right over 1, huh? All right. So if I plug in 2, I'm going to have pi over 3 plus 4 pi. 4 pi is 12 pi over 3. So 12 pi over 3 plus pi over 3 would be 13 pi over 3. And this one would be negative pi over 3 plus 4 pi, which is negative pi over 3 plus 12 pi over 3, 11 pi over 3. So there's 4 answers. Need one more k number. 1, 2, 3, 4. I only count 4. Well, because it says list 6 specific answers. So these are not specific, these are general. These are all of the answers. It wants 6 specific. Would you say k equals 8? Oh, you're being mean to me today. K equals 8. Alright, if I plug 8 in, I would have 16 pi right here. And then I got to have a denominator of 3. So 16 is 48 over 3. So 48 plus 1 is 49 pi over 3. And again, if this is 8, this is 48 over 3, so 47 pi over 3. Personally, I would not have used 8 and 2. I would have probably used k equals 1 and k equals negative 1 to keep my numbers small and make my arithmetic easy. But you guys decided to be cruel to me and make me deal with big numbers today. That's okay. Wouldn't 5 pi over 3 be 1? Yes, it would be. Because if I used k equals 1 right here, I would have minus pi over 3 plus 2 pi, which would be 5 pi over 3. So had I picked k equals 1, I would have gotten 5 pi over 3 as a specific answer, yes.
2 pi over 3. No, 3.
2 pi over 3 isn't going to work, because that's in quadrant 2.
3 pi.
Well, 3 pi over 3 is pi. That one doesn't work either. Yeah, so you get some of the odds, but not all of them.